Section 3, Regression. Hello. Now we'll briefly discuss regression, linear and logistic. These are statistical fits to data, different models, and error measures. These are often good first machine learning techniques. Linear regression is fitting a line to data, minimizing least square error. This is a standard technique in statistics. The square function gives high weight to large errors, so the line is chosen mainly to minimize those. The output is a number which in our case ought to be correlated with the chance of diabetes, but it's not a true probability. It can be less than 0 or greater than 1. We can interpret values less than a cutoff, ideally 1/2, as no and greater as yes to get our diabetes outcome prediction. The equation is a familiar line, and changing the value of one of our input variables will produce a proportional change in the output. Logistic regression fits a sigmoid function, usually an exponential, to data but with asymptotes, in our case 0 and 1, for large positive and negative values of input variables. So, no matter how big or small the input values get, the output will always be in the interval 0 to 1 and is meant to represent a probability, in our case the probability of diabetes. So we'll take an output less than 1/2 as no and greater as yes. Arbitrarily, I'll call exactly 1/2 a no because most people in our training set do not have diabetes. There's a region where the curve is steep, and a change in input variable will mean a large change in output probability, but away from that region, the curve is less sensitive. For probabilities near 0 and 1, it takes a large change in an input variable before we see any difference in output probability. The steepness of the center region can be adjusted by a parameter.